Hello students, let us start with our next science chapter, chapter 13, that is motion and time. In this chapter, we are going to learn about speed, we learn about measurement of time, unit of time and speed, measuring speed. We will also learn about odometer and speedometer and distance time graph. And how do we make these graphs? So let us first understand what is motion. Motion is the change in position of an object with time. There are two different types of motions that we will study in this chapter. That is rectilinear motion, where motion happens along a straight line. You might have seen it when a car moves in a straight line. We will also learn about periodic motion. Periodic motion is essentially a repetitive motion. That means that pattern keeps repeating over time. For example, the motion of a pendulum can be called as repetitive motion. We will also learn about circular motion. Circular motion is a motion which occurs in a circle. So examples would be motion of Earth around the sun. Because the Earth travels in a circular orbit around the sun, we will say it is circular motion. Now let us look at various examples of motion. Motion of soldiers in a march past is in straight line, so it is rectilinear. A bullock cart moving on a straight road is again in a straight line, so it is again rectilinear. Hands of an athlete in a race is periodic motion because they keep repeating. Pedal of a bicycle in motion is occurring in circular direction, so it is circular motion. Motion of the earth around the sun again is a circular orbit, so it is circular motion. Motion of swing and motion of pendulum are repeating itself again and again, so these two are called periodic motions. Now let us understand how to find out speed. So speed is essentially the distance that an object covers per unit time. That is called the speed of an object. So, if a car covers a distance of 100 kilometers in 1 hour and a bus covers a distance of 50 kilometers in 1 hour, then the speed of the car is more because the speed of the car will be 100 kilometers per hour, whereas the speed of the bus will be 50 kilometers per hour. So, we can say that the speed of car is more than the speed of the bus. Since the speed of most objects is not constant, the speed is taken as an average speed. So the formula of finding the speed will be total distance covered upon the time taken by this object. Now let us understand about two types of motion, that are uniform and non-uniform motion. If the speed of an object is constant, that means if the speed is same, then it is uniform motion. And if the speed of the object keeps fluctuating, that is, it keeps changing, then it is a non-uniform motion. We observe these types of motions in various ways in our day-to-day life. We observe uniform motion in case of pendulum, where it keeps the same speed, whereas the speed of a car or a bus on a road is changing over time. So it is an example of non-uniform motion. In order to find the speed, we need measurement of time. So let us understand how do we measure time. Time is measured by using clocks or watches. We ask about time during various times in our day-to-day life. So clock and watches follow periodic motion like a simple pendulum. A simple pendulum has a metallic bob which is suspended from a strand by a thread, as you can see in this picture. Now if the bob is taken on one side and it is released, then it will move to and fro and it will keep repeating this pattern every time. So because it is repeating this pattern, we will call this as periodic or oscillatory motion, because there is oscillations happening here. We can even count these oscillations. So when the bob moves from its mean position O, mean position is essentially its original position. So here O is the mean position. When the bob is moving from O to A and to B and back to O, this is called one oscillation. You can see in the figure, this is the mean position O where it is there originally. Now, when something happens to it, a force is applied to it, then it will move from its mean position. That is, it will go to extreme positions which are A and B. Now, let us understand what is time period. So, time period is the time taken by the pendulum to complete one oscillation. So, when it is completing one oscillation from A to B and it is coming back to its original position, we call it as time period. So when the bob moves from the mean position O to A and to B and back to O, we say it is one oscillation. And when the bob moves from one extreme position A to another extreme position B and then back to A, that is also called as one oscillation. Now let us calculate time period using an example. So if the time taken for 20 oscillation is given here, which is 42, then we divide 42 by 20. So the answer will be 22.1. So that is the time period. Similarly for 44, again because it is 20 oscillation, we'll divide it by 20. So it will be 2.2. So essentially it is moving from one position to another to complete this oscillation. For 47, the time period is going to be 2.35. Now let us understand the units of time and speed. So the basic unit of time is second. The larger unit is minutes, hours, days, because that depends on what we are trying to calculate. And the basic unit for speed is meter per second, and a larger unit would be kilometer per hour when we are traveling over long distances. During ancient times, people did not have modern devices like watches to measure time. So they used devices like sundial, water clock and sand clocks to measure the time. These devices did not give the absolute accurate measurement of time, but they did give them an idea about the time of the day. So now that we know all the formulas, we can do various numericals based on these. The speed of an object can be measured if we know the distance and the time. Similarly, distance can be measured if we know the speed and the time, and time can be measured if we know the speed and the distance. So if a car covers a distance of 100 kilometers in 2 hours, then the speed of the car would be distance upon time. So it will be 100 divided by 2, which is 50 kilometers per hour. Now, if we know the speed of the car and the time, we can easily find the distance covered by it. So, distance will be speed multiplied by time. So, here because the speed is 50 and the time is 2, we will multiply 50 by 2. So, the distance is 100 kilometer. Similarly, we can find the time also if we know the distance and speed. So, if the distance is 100 and the speed is 50, then the time would be 2 hours. So this way we can solve various examples of finding out speed. Now if group A has a distance of 1.2 meters, time is 2 seconds, then the speed will be distance upon time, so 0.6 meter per second. Similarly, the distance and time for group B, C and D are given. So we can calculate their speeds. So the speed for group B is 0.5 meter per second, C is 0.4 meter per second and D is 0.5 meter per second. So the fastest group is obviously group C with a speed of 0.4 meter per second. Now let us learn about speedometer and odometer. Speedometer is a device which measures the speed of a vehicle in kilometers per hour, and odometer is a device which measures the distance covered by a vehicle. We often see this in various vehicles. So next time you sit in a vehicle, just notice for the speedometer. Here the speedometer is showing the speed as 100 and the odometer is showing the distance which is travelled by the vehicle so far. Now let us understand how to make a graph. So in a graph there is a point O which is at the center, as you can see in the figure, that is the origin. Then we have x-axis. X-axis is the horizontal axis of a graph, and then we have a vertical axis which is y-axis. So in the pink region we will plot all the positives. So now let us see how to plot these distance time graph. Now while plotting graphs, we always plot the independent variable, that is the one which we are changing on the x-axis, and the dependent variable, that is one which we are measuring on the y-axis. Now in this table, we are changing the time and the distance traveled by the car is given. So here the graph will be as follows. So you can see this is how we plot a graph where we have taken time in minutes on the x-axis and distance in kilometers in the y-axis. Now if the distance travel graph is a straight line, that means that the object is moving with a constant speed, that is, it is traveling with the same speed. If the speed keeps changing, then the graph can be of any shape depending on the type of changes that are happening. We can also have different types of graph based on the needs. So when we are plotting something like composition of air, where we see different components of gases, we can use a pie chart. Whereas if we are plotting the runs scored by a team in each over for a cricket match, then we can use bar graph as shown in the figure. In some cases, we will also need a line graph. So a line graph will show the change in weight of a man with age. Here we plot the points like we do in a normal graph and then connect them using a line. Now let us summarize all that we have learned in this chapter. So in this chapter, we have learned that the distance moved by an object in a unit time is called its speed. Speed of objects helps us to decide which one is moving faster than the another. The speed of an object is the distance traveled divided by the time taken to cover the distance. The basic unit is meter per second. We also learned that the periodic events are used for measurement of time. Periodic motion of a pendulum has been used to make clocks and watches. Motion of objects can be presented in a pictorial form by their distance and time graphs. The distance time graph for the motion of an object moving with a constant speed will be a straight line.